linear recursion. What is linear recursion? We know that in the recursion, we need to have a base case. So the base case is testing. So there should be at least one base case. It is to test for a set of base case. So let's say if the number already 0 or if the number is 1, then we will stop. So every possible chain of recursive calls must eventually reach a base case. And the handling of its base case should not use recursion. This is the basic idea of the base case. If we do the recurrence, so it will perform at least a single recursive call. So this step may have a test that decides which of several possible recursive calls to make, but it should ultimately make just one of these calls. And we need to define the possible recursive call so it makes progress toward a base case. So this is by the definition. Let's see the example. Okay, we have this case, the linear recursion. I think we already learned about this one. So we have the A, which is the array, and then N is the number that we want to start. The input is the integer array, which is A, and N. So such that N has N element. And the output is the sum of the first N integers in A. Okay, so in the algorithm, you will have input and output. If N equals to 1, then returns A0. So I want to get the A at index 0. If not, then do the linear sum given the array A, and then let N be minus 1. And then we will do the element with A and minus 1. So let's say if I give A and then I give comma 5, then I will do the A index A index 4 plus the algorithm. Again, we will call this algorithm by using the linear sum of A, linear sum of A, comma 4, and then plus A index 4. If we have N equals to 5. And then, yeah, you can see from this one, linear sum A, comma 5, and then we have linear sum A, comma 4, we have linear sum A, comma 3, until N equals to 1. If N equals to 1, then we will just get the A index 0. And then we will do the summation. We will do the summation and we return back the total of the summation. Reverse array, we want to swap. So in the reverse array, A, I, J. So we want to swap. For example, I have an input, which is an array, and then we have non-negative integer. What does it mean, non-negative? We usually have the non-negative, it is equals to positive. But we say non-negative because the positive we usually start from 1. If we call non-negative, we can start from 0. So this non-negative integer index I and j. The output is the reversal. The reversal, it means the reverse of the element A starting at index I and ending at index j. So for example, I have the data. Do I have any data here? Yes, I don't have it. Let's say I have 5, 3, 4, 6, 7. Okay. So I want to reverse this list, and the result will be 7, 6, 4, 3, 5. So this is the meaning by reverse. Each of the element, if this one is index 0 and then this is index 4, so we want to swap. So index 4 will be in the first, index 3 will be on the second, and then the middle value will be the same. So we can make the algorithm. If I is less than j, then swap ai and aj. So the reverse array a, I plus 1 and j minus 1. It means I is starting from 0 and j is the last index 4. So if I, this is 0, less than j, which is 4, then swap. And then we will do again the reverse array by adding this one into 1 and minus this one into 1, which is 1 and 3. So we can swap between the index 1 and index 3. And then this is plus 1, this is minus 1. Because I is not less than j, then stop the method. So we can make this recursion. In creating the recursive methods, it is important to define the method in ways that facilitate recursion. Sometimes requires we define additional parameters. They are passed to the method. For example, we can make the reverse array A, I, J instead of only reverse array A. Yeah, it depends on how you define it. If we want to make the A, I, J, then I make the argument. S is the sequence for the array, and start is the index of the starting, and then stop is the index that we want to stop. So if start less than stop minus 1, we will swap. Okay, do you know what does it mean by this one? Start. Yeah. S is the sequence in the index position start, comma, S is a sequence in the index stop minus 1. It will be the S stop minus 1, comma, S start. So it is the swapping procedure. If this one already swapped, let's do again the reverse by calling the S start plus 1 and stop minus 1. So this is the recursion. We can make also the recursion for computing powers. Computing powers. It means if I have p x comma n, then x will be the base for the exponent and n will be the exponent. The exponent means this one, x power of n. If I have p 2,5, it means it is 2 power of 5. Now, if n equals to 0, so if n equals to 0, it means, let's say I have p, okay, 2,5. So n is starting from 5, and then we have this one, x multiplied by p x n minus 1. Then it will be 2 multiplied by p 2,4. And then again we have 2 multiplied by 2 multiplied by p 2,3 and so on. So the n, when the n is 0, then it will be 1. So 2 power of 0, it will be 1. If we use this function, so this leads to a power function that runs in O(n) time. So we will do until n times because we make the recursive call. So can we do better from this one? So there might be a more efficient way to make the linear recursive algorithm. So if x is odd, we can use this function. And if x is even, you can use this function. So what is the difference? So let's say if we have 2 power 4, okay, we can see this algorithm. Let's say p is 2,5. Okay. Then it will be 2 power of 5. Then the problem can be something like this one. 2 power of 1 plus 4 divided by 2 multiplied by 2. So it means we have p 2, this one 1 plus 4 divided by 2 multiplied by 2. This happens when x is odd. But when x is even, okay, if it is 2,4, let's say, then we can just have p 2 4 divided by 2 multiplied by 2. So something like this one. We know from the mathematical, the algebra, okay, 2 power of 1, it means 2 multiply by 2 power of 4 divided by 2 multiply by 3. Then it is 4. So we can make this one a recursion until we have only 2 power multiplied by 4 power of 2. So using this formula, you will do for every n will be divided by 2, will be divided by 2, will be divided by 2. So the algorithm will be something like this one. If n is 0, then return 1. If n is odd, then we have the power, which is the name of the algorithm. We have power x n minus 1 divided by 2. So the return will be x multiplied by y multiplied by y. If n is even, then we can use y equals to the power x n divided by 2. And we will return y multiplied by y. So we will just skip the x when it is even. Now how we can understand this analysis? Each time we make the recursive call, we have the value of n. So we make it half. Because we make it half, it means when we do this recursion, we have log n recursion. So we don't make n times. So the proof is one. If we use this one, we will do n times because we will do from n and then n minus 1 and then again n minus 1 until n equals to 1. But here we make it half. When we make it half, it means we can make it log n recursive call, so not until n times. Thus, this method runs in O log n time. So it is important that we use a variable twice here rather than calling the method twice. Okay, so if you look at the code, I give you the power. So this is the function power base comma exponent. So if exponent equals to 0, then return 1. Else if exponent equals to 1, it is base. And we will do the base multiplied by power base comma exponent minus 1. So using this one, it is the n on. So this is on, because we will do every number in the exponent. So this will be n times or linear time. If you later on, you can try how to make this one and how can you modify from the code that I already give for this exponent. Okay, so you can try how to modify this one according to the algorithm of this recursion. Then, what is the meaning by linear recursion? The linear recursion means you have only one time of the recursion. One time means like this one. You call only one. And then you call this function only one. So we call this is the linear recursion. There are some variants from the recursion. We have tail recursion, binary recursion, and multiple recursion. Okay, the tail recursion and binary recursion, we will learn about it, but I will skip the multiple recursion. The tail recursion. What is tail recursion? By the definition, tail recursion occurs when a linearly recursive method makes its recursive call as its last step. So we call this is tail recursion. So the example is the array reversal method. But maybe some of you, if you already understand about for loop, if you understand the for loop, you may ask that what is the difference between the recursive and the non-recursive method? For example, I can do like this one. While I less than j, if this one true, then swap. Okay. So what is the difference? Actually, no difference. The result will be the same. The output is the reversal of the element A starting at index I and ending at index J. The only difference is the way to swap. In this case, we use a for loop, but using the recursion, we will call again the method. So it means when you want to solve one problem, you can solve with the for, or you can solve with the recursion. And if the recursive method happens in the last, we call it this is tail recursion. Okay, I will stop here. Please go to the e-class and you can do the learning check.